Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Aziz bin Ahmad Azri, and I am from class AS1211B. And the topic that is given to me is liquid coal, producing liquid fuel from non-petroleum sources. First, let us look at the table of contents. The first one is introduction to coal. The second one is overview of liquid coal. And the third one is methodology in producing liquid fuel. And the last one is pros and cons of using liquid coals. Let's get straight into the first topic, that is introduction to coal. What is coal? Coal is a combustible black or brownish black sedimentary rock formed as rock strata called coal seams. It is formed when dead plant matter decays into peat and is converted into coal by the heat and pressure of deep burial over millions of years. Coal is mostly carbon with variable amounts of other elements, chiefly hydrogen, sulfur, oxygen, and nitrogen. Next, let's look at the overview of liquid coal. Liquid coal is coal converted into liquid fuel using a massive amount of water and energy. The purpose is to increase emissions of greenhouse gases, encourage strip mining and other harmful coal mining practices like mountaintop removal, and consume an enormous amount of another vital resource such as water. Coal liquefaction originally was developed at the beginning of the 20th century. The best known CTL process is Fischer-Tropsch synthesis, or also known as FT. Named after the inventors Franz Fischer and Hans Tropsch from the Kaiser Wilhelm Institute in the 1920s. The FT synthesis is the basis for indirect coal liquefaction (ICL) technology. Friedrich Burgers, also a German chemist, invented direct coal liquefaction, or also known as DCL, as a way to convert lignite into synthetic oil in 1913. Coal liquefaction. Coal liquefaction is the process of converting coal into liquid hydrocarbon fuel. There are two basic approaches to converting coal to synthetic fuel, that is direct coal liquefaction, or also known as DCL, and indirect coal liquefaction, or also known as ICL. Let's look at the direct liquefaction first. There are two processes for direct liquefaction, that is solvent extraction or Burgers process, and pyrolysis and carbonization or Carrick process. The Burgers process is a method for the production of liquid hydrocarbons such as gasoline, diesel, and jet fuel for use as synthetic fuel. This method was developed by Frederick Burgers and patented in 1913. The process involves the hydroliquefaction of brown coal, also known as lignite, into crude oil. The brown coal is ground into a fine powder and heated at 425 to 480 degrees Celsius under 200 to 700 atm pressure of hydrogen gas in the presence of a catalyst, iron, molybdenum, and tin catalyst have all been used. The catalyst used initially was molybdenum oxide in the presence of sulfuric acid, but iron catalysts are the most common owing to their lowest cost and higher availability. The Carrick process. The Carrick process is a low temperature carbonization process which uses a hermetic retort for commercial scale production. A retort about 3 feet in diameter and 20 feet high would be used. The process of carbonization would last about 3 hours. Superheated steam is injected continuously into the top of a retort filled by coal. At first, in contact with cool coal, the steam condenses to water acting as a cleaning agent. While temperature of coal rises, the destructive distillation starts. Coal is heated at 450 degrees Celsius to 700 degrees Celsius in the absence of air. The carbonization temperature is lower is lower compared with 800 degrees Celsius to 1000 degrees Celsius. For producing metallurgic coke, the lower temperature optimizes the production of coal tars richer in lighter hydrocarbons than normal coal tar, and therefore it is suitable for processing into fuels, resulting water, oil and coal tar and syngas moves out from retort through outlet valves at the bottom of the retort. The residue remains in the retort, while the produced liquids are mostly a byproduct. The semi-coke is the main product, a solid and smokeless fuel. The Carrick LTC process generates no carbon dioxide, but it does produce a significant amount of carbon monoxide. Indirect liquefaction. Indirect liquefaction contains two stages and three main processes. In the first stage, coal is converted into syngas. Syngas is a purified mixture of carbon monoxide and hydrogen gas. In the second stage, the syngas is converted into light hydrocarbons using one of the three main processes. The three main processes are Fischer-Tropsch synthesis, methanol synthesis, and methanation. Fischer-Tropsch synthesis. The Fischer-Tropsch process is a collection of chemical reactions that converts a mixture of carbon monoxide and hydrogen or water gas into liquid hydrocarbons. This reaction occurs in the presence of metal catalysts, typically at temperatures of 150 to 300 degrees Celsius and pressures of 1 to several tens of atmospheres. In methanol synthesis process, syngas is converted to methanol, which is subsequently polymerized into alkanes over a zeolite catalyst. This process under the moniker MTG for methanol to gasoline was developed by Mobil in the early 1970s. Methanation reaction converts syngas to substitute natural gas, or also known as SNG. There are many pros and cons of producing liquid coal. Let's go to the advantages first. The advantages of producing liquid coal is they possess higher calorific value per unit mass than solid fuels. They burn without forming dust, ash or clinkers. Their firing is easier and also fire can be extinguished easily by stopping the liquid fuel supply. They are easy to transport through pipes. They can be stored indefinitely without any loss. The flame produced by burning liquid coals can easily be controlled by adjusting the liquid fuel supply. Liquid coals are generally handled by pipes, and one man can easily regulate a large number of furnaces simultaneously. The disadvantages of producing liquid coals are the cost of liquid fuel is relatively much higher as compared to solid fuels. Costly special storage tanks are required for storing liquid coals. There is a greater risk of fire hazards, particularly in the case of highly inflammable and volatile liquid fuels. Liquid coals give bad odor. For efficient burning of liquid coals, specially constructed burners and spraying apparatus are required. Choking for sprayers is a drawback of firing. Recommendation: identify, implement, and train workers in best practices and employing dedicated and plant efficiency engineers. Optimize processes using advanced computational tools and software. Conduct online, real-time performance monitoring of efficiency. Reduce air, water, steam, and flue gas leakage. Optimize coal pulverizer performance and balance coal and air flows to the burners. I think that is all from me, Ahmad Razid bin Ahmad Nazri. Thank you for listening my presentation.